Hello everyone and welcome to this brand new video in Python Deep Learning using Keras series. And today we are starting the second chapter, which is the mathematical building blocks of neural networks. In this chapter, we are going to take a look at the first part, which is the first example of a neural network. So if you've never built a neural network in your life, this is your chance. Today we will be building our very first neural network with Keras. So enjoy the video. In the last chapter, we had the refresher of what deep learning is in very basic way. In this new chapter, we are going to talk about the mathematical building blocks of neural network. So this chapter begins with the first look at a neural network, which is the most basic neural network that you should know how to build. And the dataset involved is MNIST dataset. We have also talked about it in the previous chapter. As you can see, I have the book open on one side and a Kaggle notebook on the other side. I will also be providing the link to this Kaggle notebook in the description. So do take a look later if you want to. In this problem, the problem that we are solving today is classifying grayscale images of handwritten digits. That is your 28 cross 28 pixels into 10 different categories, 0 through 9. And we will be using the MNIST dataset. And it's a classical dataset in machine learning community, which has been around for almost as long as the field itself. And it has been studied intensively. So the dataset is huge. It consists of 60,000 training images, and there are 10,000 test images. So as the author also mentions that you can think of solving MNIST as the hello world of deep learning. So if you're building an algorithm, you can try it on the MNIST dataset and see how well it works. So there will be a lot of things in today's video that you might not understand, since we're just starting with this book. But eventually you will get to know everything. So don't worry about it if you don't understand it. So the first thing we do is, as you can see, this is how the dataset looks like. So you have images, and every image has a number associated with it, number in it. And these images are 28 cross 28 pixels. So this is 28 and this is 28. Same here, 28, 28. So let's first try to load the MNIST dataset in Keras. So what we will do is we will import MNIST from TensorFlow Keras datasets from tensorflow.keras.datasets import MNIST. So one thing about this notebook that you should know, that I have turned on internet, and I also have GPU enabled. So once I've imported MNIST, I can call the load data function to load the data into memory. So I have train images, train labels. I have test images and test labels. So they come in this format, where you have training set and validation or test set together, and we say MNIST dot load data, and it might take a while depending on your internet speed, so it's going to download. But see, it was super fast on Kaggle kernels. So now we have loaded the dataset, and we can see that the images are encoded as NumPy arrays, and the labels are arrays of digits. How do we verify that? We can just do train images and see what's inside them. And if we do a shape of train images, we have 60,000 in the first axis, and then 28 cross 28. So it's 28 cross 28, and that's your training set. And similarly, you have, I can just write here, test images.shape. And this will be 10,028 cross 28. And similarly, we have train labels. So train labels will be just a value associated with all the samples, and the shape of this will be 60,000. Similarly for test images.shape. Okay, sorry, test labels.shape. So now you see 10,000. Great. So we have loaded a dataset, and that's the first step that we need, is to have the training and test images. So now what we are going to do is we are going to build a very simple network. And for that, we will be using Keras, obviously. So from TensorFlow, import Keras, and from TensorFlow.Keras, import layers. Okay, so once you have imported that, you can build your network. And we are using sequential model. So as I said, there will be a lot of things in today's video that you might not understand, but just bear with it and try to build this neural network on your own, and then it's going to be quite easy for you. So we will add a dense layer, and we will provide it with the activation ReLU. And we will add another layer, and this is also a dense layer, and here we have 10 outputs, and activation is softmax. So we will also read about activation. The thing that here you want to know is this is the output layer, and this is single layer neural network. I forgot to add a comma here. Okay, so this will be your model. If you print your model, so it's a sequential model, and you can also visualize the model by doing model.summary. Okay, so for that, we have to build the model first. So as we know from the last video, the core building block of neural network is the layer. So you can think of layer as a filter for data. So some data comes in and it gets transformed, it gets passed to the next layer. So in our case, we have only one layer, and the another layer is our output layer. So the data gets transformed from this layer, and it's sent to the output layer, which says, okay, what is the probability of the image being a 0 or 1 or 2, and so on. So these layers are extracting representations out of data and data fed into them, and hopefully you hope that these representations are going to be more meaningful for the problem at hand. So now in our model, as I explained before, we have two dense layers, also known as fully connected layers. And the second and the last layer is the 10-way softmax. So like it will output some probabilities, and the probabilities will always sum to 1. And each probability will be the score of the current image. So in the previous chapter, we learned that we need 3 things. One of the things is an optimizer, the mechanism through which model is going to update itself. So for your compilation step, you need 3 things. So these 3 things are a bit different from the 3 things that you need to train a neural network. So to compile the model, you need an optimizer, a loss function, and metrics that you want to monitor. So metrics are usually optional. So what we are going to do here is we are going to write model.compile. So what your optimizer does is it's a mechanism which the model will update itself based on training data. So we add optimizer, and here we have chosen RMS prop. We can also choose SGD or Atom. There are many different types of optimizers. Loss is sparse categorical cross entropy. And don't worry much about it right now. And the third thing that you need is metrics. So metrics is a list, and inside this list we can add things like accuracy. And now we can fit the model. But before fitting the model, we need to prepare the dataset. So like our dataset is in the format of 60,000, 28. So what we are going to do is we are going to flatten it. So it will become 60,000 and 28 multiplied by 28. Multiplied by 28. So something like this. And to do this, we can do train images equal to train images dot reshape. So these are basic NumPy operations. And here I can write 60,028 into 28, or I can also write -1. And now my train images dot shape is 60,000, 784. Okay. Similarly, we can also reshape the test images. And now what we are going to do is we are going to normalize these images. So I will say the pixel values can range from 0 to 255. So we will just divide everything by 255. Train images equal to train underscore images dot as type. So we convert it to float 32 and we divide by 255. Similarly, we do it for test images. Okay, so now our train and test images have values between 0 and 1. And now we can fit our model. So we just call the model.fit function, pass in train images, train labels, and we pass the number of epochs and batch size, 128, let's say. Okay, so now our model is fitting for 5 epochs. So it's going to see all the data 5 times. And now we can print model summary. So here you can see it's a sequential model and has 2 layers. First layer outputs 512, second layer outputs 10. And the total number of parameters in this model is 407,000, and all are trainable parameters. So all these parameters are getting trained when you call model.fit. Okay, and now if we have to make our predictions on the test set, we can say predictions equal to model.predict test images. And it has created some predictions and they look like this. So now what it means, if you call the shape, you will see it has 10 values. And or if I look at sample number 0, I see that it has many different values ranging from 0 to 1. So this is the highest value I found. And if I take the sum of this should add up to 1 or almost 1. Okay, so these are your predictions. So for each sample in the test set, you have predicted a bunch of probability values. And if you want to see like if my first sample in test set, which value it is, what you can do is you can see like this is 0, this is 1, this is 2, 3, 4, 5, 6, and 7. So 7 has the highest probability, And if I look at test labels 0, it should be 7. If it is 7, then our neural network is performing quite well. And here you can see when it was training, it was giving a training accuracy of 97, 98, 98%. So it's a training accuracy calculated on the training dataset, not on the test dataset or the validation dataset. And we will also learn about them later in this chapter. So now you can also call model.evaluate. So you have a test loss. So here we are also printing the loss. So you see the loss starts very high, and as the model is training, the loss keeps getting lower and lower. And this loss is on the training set. So what we can do is we can call model.evaluate. Training accuracy is test loss, and test accuracy is model.evaluate. And here you provide with the test images and test labels. So this is evaluated, and now you're getting an accuracy of 98.24%. And the loss is 0.06. So you see this loss is a little bit higher than the loss we had for training data, which is okay. So we got 98.24, and here we were getting 98.88. So this accuracy is also a little bit lower because your neural network starts to memorize the training images. So if it has not seen the test images, and if you train for too long, you will probably get an accuracy of 1.0. So that's it for this video. In this video, we learned to build our first neural network based on MNIST dataset. There were a lot of things that we are not familiar with. There were a lot of things that you probably wouldn't understand if you're not familiar with Keras, but that is perfectly fine. In the next videos, we will learn in depth of what each and everything, like what sequential means, what model compile is, what layer.dense is, what are activation functions, and everything else. So, but you have built your first neural network using Keras without too many lines of code. So that's how easy it is to work with Keras. And if you like the video, do click on the like button, do subscribe, and do share the video with your friends. Thank you very much.